Okay, so again, I'll repeat what I said. This is where I need your focus, polyatomic ions. And we just talked about this. Polyatomic, okay, poly means many, atomic means atom, ion, we're talking about something with a charge, okay? So what I was going to say is, yeah, this is going to be a pain. What we've talked about so far are things like Cl1 minus, right? Okay? That's one atom that has a charge. Or Na1 plus. That's one atom that has a charge. Polyatomic, it's a group of atoms together that overall have a charge. So some examples. Okay, NH4 1 plus, CO3 2 minus. Okay, those sorts of things, these are polyatomic. That means they have more than one atom, but they have a charge. Okay, and you can treat them just like one of these. So they're not all that different, they just look a little bit different. For polyatomic, let me go back to this. Ions that are made up of more than one atom, okay? And these could be cations or anions. They could have a positive charge or a negative charge. Most of them are anions. Okay, so what you will see down here on your notes under letter B are a bunch of examples of common polyatomic ions, okay? NO3 1 minus is called nitrate. NO2 1 minus is called nitrite, carbonate. So you've got all these different ions here. There is a website here you can go to, the Quizlet, if you want to just look at some of these. Here's the thing. You don't have to actually memorize these, okay? Which should be good news because they're fairly difficult to memorize. I'm going to give you a chart right here. This has got the polyatomic ions that you would need. And you get to use these on quizzes and tests, all right? So you do not have to memorize these. You just need to know how to use them. Okay, so there's your polyatomic ions. Now, just something I'll mention here, okay? And again, doesn't really matter that much to you guys because you have the list right here. But notice, NO3 1 minus is nitrate, right? Look at nitrite. What's the difference between nitrate and nitrite? Spelling, yes. One of them has 3 oxygens, the other one has 2 oxygens, right? Now the charges are actually the same. They both have a 1 minus charge, right? Okay, but the number of oxygens are different. So actually that's what distinguishes the ate ending from the ite ending, okay? But those endings are important because that's going to tell you when you need to use a polyatomic ion or not. If you have the name of a compound and it ends in ATE or ITE, that's going to tell you, oh, okay, this is a polyatomic ion. I need to look at my chart. All right, you need to know when to look at this. Okay, so I'll show you several examples here. Okay, but the way that you write these when you are naming them, or actually, I guess we're going to write formulas first. Okay. Where are we? Yeah, I know, but... Oh, okay. So the example here that we're going to use as we're walking through this is calcium nitrate. So if you want to write that above C somewhere, I'm sorry, there's not a lot of room there, or beside C maybe. We're going to show you calcium nitrate as we go through this as far as the steps. Okay? So when you're going from the name to the formula, again, what's your clue here that we're using a polyatomic ion in this one? If you look at that name, it ends in ATE, right? That's nitrate, okay? Now, what would it normally end in? What's the ending we've been using up to this point? IDE, right? Okay? So if it ends in IDE, you just name it the way that we have been, or you write the formula the way that we have been. When you have this ending, ATE, ITE, something other than IDE, basically, okay, that's when you know that you have a polyatomic ion and you need to look at your chart, okay? So we're going to write each ion, cation first, then anion. And I still don't think it's going to let me write on this. Okay, so let me go back to my... What's that?
Right on the board so you can still have that up. You don't have to go back here. Well, that's the video.
Well, yeah, but I'm doing the video right now, so it's got to be on here. Okay, so calcium nitrate. The first ion is calcium. What's the charge for calcium? 2 plus, okay? That should be relatively easy, okay? Now, nitrate. What is nitrate? It is nitrogen. Okay, but you don't have to remember it. Nitrate, oh, I should look at my chart, right? Okay. So nitrate is NO3 1 minus.
Is that what we can crisscross?
Yes. On these you can crisscross, all right? Now, the crisscrossing is a little tricky on these
Are you supposed to 3 over 2?
because you've got a group of elements here. So let me go back to the PowerPoint and make sure I'm following along with that. It says use the crisscross method using parentheses when necessary. Do you guys have to fill anything out here?
No.
No, it's already filled in. Okay.
We should probably use parentheses for that.
If two subscripts are right next to each other, separate them with parentheses. So let me show this to you. If we're going to crisscross, this 2 should come down here, right? This 1 should come down here. So if I wrote that the way that we normally write these, it would be CA1 or just CA. It doesn't. You don't have to put the 1. NO3 2. Ooh, that looks like NO32, doesn't it? That doesn't quite work. So what you want to do, you want to show we need 2 of the NO3s, right? So if I put a parentheses right here, that separates the 2 subscripts from one another. So now I can show, okay, we've got 2 of the NO3s in that compound, not 32 oxygens. Okay? Does that make sense? So make sure you're using those parentheses when you're working with polyatomic ions. Okay, parentheses become very important. In fact, I would recommend just putting parentheses around your polyatomic ions all the time. It's never going to make you get something wrong, okay? Sometimes you won't need them if there's just a 1 plus charge over here, okay? But that way you just get in the habit of always separating that polyatomic ion as a unit, okay? All right, so reduce if necessary. You can't reduce any subscripts found in the polyatomic ion ever. What that means is do not change this ever, okay? Any subscript that's in the polyatomic ion itself, never, ever, ever change that.
Like the charge is on
Yeah, let's say,
it was like 2 and a 4.
yeah, for example, you had something like that, okay? Then you can reduce that down to CaNO3 okay? But don't ever change that 3 or whatever it is in the polyatomic ion, okay? Good. So CaNO3 is the answer on that one. Let me go back to the... Let's see this. All right. So that's that. Now we can do some examples here, which I think the examples are... Let me make sure they're the same on your notes. Whoops. Oh, okay. It's actually doing the first step for you on the notes. Sodium sulfate, iron 3 hydroxide, ammonium carbonate. Okay? Yes. And the answer key for this will be on. All right, so sodium sulfate. If we're trying to name that, we need to figure out what the ions are. Or, I'm sorry, if we're trying to write the formula for that, we need to figure out what the ions are first. Okay? What's the ion for sodium? I'm asking you a question where you have the answer in front of you on your notes. It's just Na1+, right? Everybody okay with Na being a 1+? Okay. Sulfate, where did that come from? Sulfate. 8, right? Okay, if it ends in ATE, look on your chart.
How do you say that?
SO4 2 minus. That's how you'd say it. So you just say the 2 atoms you have there and then say the charge at the end. Okay? All right, so everybody see that sulfate is SO4 2 minus. And all you have to do, you don't have to memorize that, you just look on your chart. It will tell you. Okay? So if we've got Na1 plus and SO4 2 minus, thank you, then the way we would write that, and I'm going to stay over here for a minute, I think. When I crisscross my charges here, what is this going to be? Na2, SO4, you could put a 1 out there, you don't really have to, okay? This is one of those situations where you don't really need the parentheses, but you do not have to put the parentheses there. I'm okay if you write it, though, okay? Doesn't matter. I'm even okay if you put a 1 out here, all right? But that's not necessary. On this one, the parentheses are not necessary, the 1 is not necessary, okay? So the way you'll typically see this written is like this, Na2SO4, okay? Everybody all right with that one? Okay, the next one, iron 3 hydroxide. So that's Fe3 plus. How do we know that's Fe3 plus? Because of the Roman numeral 3, right? Okay, and then OH minus. Where did that come from? Okay, so you know how I told you if it ends in ATE, you look on your polyatomic ion chart? Well, there's a couple of instances where you need to look on your polyatomic ion chart, even if it ends in IDE. So I need you to hear me here, all right? That's probably a good idea. One of them is hydroxide, okay? Now, that kind of sounds like a polyatomic ion if you think about it, doesn't it? What 2 elements does it sound like are in there? Hydroxide. Hydrogen and oxygen, right? That sounds like a polyatomic ion, okay? So hydroxide is one. You just got to remember that one. You need. Yeah, peroxide is on there as well, okay? And the other one is cyanide, okay? Amide, A-M-I-D-E. You're not going to see that one in this class, really. But cyanide, you might see. Cyanide is carbon and nitrogen, okay? So those are the ones there are a few on there that do end in IDE, which is unfortunate. I wish they hadn't named things that way. But that's how it works, okay? So on that one, we've got iron 3 hydroxide, Fe3 plus, and OH1 minus. And I need to see what time we're done today. Okay, 23. 10:23, right? Okay, so Fe3 plus and OH1 minus. When I crisscross, what am I going to end up with here? Fe. Three. Just like that, right? Right, guys? Right? No, thank you. I appreciate the response. Okay, so FeOH3, all right? Ammonium carbonate, NH4 plus, and CO3 2 minus. Ooh, we got 2 polyatomic ions there. Can that happen? Sure, why not? Now, here's another tricky one, okay? Ammonium. Doesn't sound like 8 or 8, does it? Ammonium might be a good one just to remember. That one's a polyatomic ion, okay? You can search all day on the periodic table. You're not going to find ammonium up there, all right? So that one is actually one of the only ones that you're going to have experience with where it has a positive charge, polyatomic ion with a positive charge. Most of them, if you look on this list, almost all of them have a negative charge. Ammonium's got to be on there, doesn't it? Uh-oh. How did that happen? Oh, it's actually in writing down at the bottom. There is one positive polyatomic ion. It is NH4 plus, and it's called the ammonium ion. Okay? That's really the only one that you need to know. That's not quite a correct statement. There are positive polyatomic ions besides that one, but that's the one you need to know, okay? So NH4 is a 1 plus, CO3 is a 2 minus. That's carbonate. Okay? Everybody with me still? So you crisscross those, what are we going to end up with? Tell me exactly what I need to write here.
Oh my God.
Parentheses, NH4, 2. Okay, and then you can do another parentheses if you want. But that one's just CO3, 1, right? Okay? So the second one doesn't necessarily need the parentheses. You could also write it like this, and it would be fine. That's ammonium carbonate. All right? There's some other practice problems there. We'll come back to those in a minute. I want to make sure we get to the naming part today so that you guys can do some of these for practice. Okay? So, when we're naming, that's going from the formula to the name. Let's do these real quick. Okay. First thing here, how are you going to even know, just by looking at the formula, that there's a polyatomic ion in here? That's a little tricky. Maybe if there's parentheses, but remember, there aren't always parentheses necessarily. Okay. You're close. Now, 2 capital letters is what we normally have, right? We're used to like CaCl2, NaCl. Right. So, here, let me. Oh, I see what you're saying. 2 in a row.
Yeah, in a row.
Okay. That would be a good thing to look for. Now, it doesn't necessarily. Let me see here. I'm trying to think of. Bromate is a polyatomic ion. See, there's not 2 capital letters in a row necessarily, but that is a polyatomic ion. So that the 2 in a row thing is kind of handy sometimes. I had never actually thought about that before, but it doesn't always work. Here's what you're looking for, okay? And I think it says this on your under D, letter D here. They contain at least 3 elements. That's the key, all right? Everything we've done so far, you probably haven't even noticed it. Everything we've done so far, when we've written a formula, there have only been 2 elements in it. Only 2. Okay? Every single one we've done so far. If there are 3 or more elements in the compound, there's probably a polyatomic ion. Does that make sense? Yes. So you count the number of elements in the compound. All right? So let me give you an example here. CuCl2? That's just 2, okay? No polyatomic ion there, okay? CaCO3? There's 3 elements there. You see that? Calcium, carbon, oxygen. So you count capital letters, okay? If there are 3 capital letters, there are 3 different elements there, and that means you've got a polyatomic ion. If there's only 2 capital letters, there's only 2 elements, and that's just the normal naming. Okay? Yeah, you were close. So, does that make sense? That's how you identify that you're going to have a polyatomic ion. All right?
So you don't look at that number, you don't look at the number 3?
I wouldn't worry about the number 3 because, yeah, just count how many capital letters you have, okay? Once you have determined that it has a polyatomic ion in it, then what you need to do is figure out what the polyatomic ion actually is, okay? So, for example, on the one that I just showed you here, CaCO3, what's my polyatomic ion there?
Carbon and oxygen?
It's this right here, right? That's my polyatomic ion, CO3. Okay? At that point, you would look on here, on your chart. You would look for the CO3 on the left side, and it looks like CO3 2 minus. Does everybody see that on your chart? That should be the only CO3.
Yeah.
Okay? CO3 2 minus is carbonate. So you look over for the name, and that'll tell you what to call it. All right? So this one would be calcium carbonate. You just name it with the cation. The naming part will be on the quiz tomorrow as well. Yeah. Okay? We only have 3 minutes, so we got to hustle here. All right, so let's try a couple of these. So the example that they give you first is copper 2-phosphate. That's not on your thing. Here, let's skip right to the examples that you actually have on your thing. Okay, Na2CO3. Okay? It says match each set with the correct name. Yeah, I guess. Yeah, let's do the examples up here first. I'm sorry that these don't match better. Okay, so NaNO3, that's the first one. Now, we know that's a polyatomic ion, right? Because you've got 3 different elements there. Okay? So the first one is easy to name. Na is sodium, right? What's NO3? That's nitrate. So sodium nitrate. That's not too bad, right? Okay, what about K2SO4? Potassium. And then you look up SO4, and SO4, according to your chart, is sulfate. Okay? Now, the only thing that makes this difficult in any way is something you've already learned. That's remembering to put Roman numerals if you need them, right? For sodium and potassium, we didn't need Roman numerals because that's in group 1, group 2. Okay? Or actually, those are both in group 1. All right? Now, when you look further down on the ones where it says name the following, 1, 2, 3, 4, 5, 6, which of those would need Roman numerals? Just looking at them real quick. No, Ca would not. That's in group 2. Number 3 would need it, right? Would need Roman numerals. D block does need it. Yeah, for the most part. Yep. Okay. Number 5 would need it because that's copper. Number 6 would need it. Actually, number 4 would need it. Okay. All right. Let me give you the homework. We're going to do some serious talking about this when you get into class tomorrow to make sure that you've got it before we take this quiz. Okay? But I do want you to try this tonight. I will post the answer key for this on Moodle.
Are you expected to tell this?
Today?
No, yes.
No.
No? I didn't even know it was. I know, my mom watched it.
Don't leave until you get this.
Apparently we're not going to have tomorrow.
We'll see. Sorry, video people, I haven't turned this off yet. There's going to be an awkward end to the video. 4. Thank you.